Hello everyone, welcome back to this online class. I'm Francis Okech and my YouTube channel is Professor Francis Okech. In this lecture, we are going to look at the second form of the integrals, that is under trigonometric and hyperbolic substitutions. So the other form of the integrals is evaluating the integral of 1 over the square root of a squared minus x squared with respect to x. So when we have such forms of integrals, what are we supposed to do? Let me illustrate the kind of substitution that you need to make. Remember that this integral can be written as, if I decide to factor out the constant a squared, remember when you take a squared outside the square root sign, we are going to get this. So our integral will be equal to, of course, it will now be 1 over a, because when it is inside the square root is a squared. So that will be 1 over a times the integral of 1 over. Now it will be the square root of 1 minus x squared over a squared. What I've done is to factor out a squared from the square root so that we have the same problem written in this form. Now, I want us to recall the trigonometric identities. Look at, because we want an identity where there's 1 minus a certain function squared gives us another function squared. So let us recall from the first identity that you need to take note. NB, we said cos squared x. So let's use theta because already we have x here, and say cos squared theta. Let me write cos squared theta plus sine squared theta. Sine squared theta, this should give us 1. So I want this in the form of 1 minus something squared gives us another function squared. So this is what we are going to rearrange so that I have it in the form of 1 minus something. So to do this, you can either take sine squared to the right hand side, or you can take cos squared theta to the right hand side. So I'm going to take sine squared theta to the right hand side so that I have this. You'll have it as 1 minus sine squared theta. That should give us cos squared theta. So we compare this, look at what we have under the square root. Under the square root, we have 1 minus x squared over a squared. So we are going to say, let me rewrite it here. We have 1 minus x squared over a squared. That should give us something. But let's compare the left-hand side. Look at our 1. This one can compare with this. Now, we can now say that sine squared theta is the same as x squared minus a squared. So from here, what we get is that x squared, I said sine squared theta is equal to x squared over a squared. Just correction. So x squared over a squared, that should give us sine squared theta. So what we do here is to make x the subject. You see from here, when you cross multiply, you are going to get x squared is equals to, let me correct this, instead of x, it's supposed to be theta. A correction. this is supposed to be theta, not x. So this is theta. So what we do, make x the subject, so we'll have x squared being equal to a squared times sine squared theta. So when you take square root on both sides, you get x is equals to a sine theta. So this is the substitution that you are going to make. This is a trigonometric substitution that whenever you want to evaluate the integrals in part B, then you must start by letting x is equals to a sine theta. We said a is a constant. So because we know x, we must also be able to substitute the x. So dx, when you differentiate x with respect to theta, what do we get? So you write dx the theta. That should give us a is a constant, so we retain that. Differentiate sine theta, that should be cos theta. And then you can now make dx the subject. So this implies that our dx should now give us a cos theta d theta. So I told you every time you make a substitution, you must also be able to differentiate it so that you know how the corresponding differential will look like. So you see what I have ticked, dx, and this other one, x. Those are the substitutions that you need to make when you're evaluating the integrals of the form 1 over the square root of a squared minus x squared. So let me give you some example, maybe one or two, to be able to illustrate this concept. Example, part A, you write part A. Let's say you are asked to evaluate the integral of 1 over the square root of 25 minus x squared with respect to x. So what do you think is our A? Compare with the form in part B, because a squared, it is a square root of a squared minus x squared. So a squared is 25. So that means a will be the root of 25, which is 5. So we can say, just take note that a squared is equals to 25. So this simply means that in this case, a should be equal to 5. So we say let x be equal to a sine theta. So we are saying x is equals to our a, that is 5, sine theta. Let x be equal to a sine theta. So when I replace a, I get that one. Now, what about the x? What will it be equal to? So you'll say, because I have to differentiate x with respect to theta, when I differentiate, I am going to get the x. Then we differentiate and then cross multiply. So dx will give us 5 cos theta d theta. So if we go back to our integral and substitute these two, let's see what you're going to get. So this will now give us the integral of 1 over the square root of 25 minus square x. Remember, x is 5 sine theta. So when you square that, you get 25 sine squared theta. Sine squared theta. Remember this, the theta. Dx, which we have said So instead of writing dx, let me rub that d. Dx we said should give us 5 cos theta. So that's what we write here, because I told you everything must be in terms of theta. So dx will now be 5 cos theta d theta. We can simplify this. Look at what we have under the square root. 25 is common. You can factor out 25 so that this is what you have. Because when you take it outside the square root, it becomes 5. And so we have this, the integral of 1 over 5 times the square root of 1 minus sine squared theta. And remember, we are multiplying by 5 cos theta d theta. So if you look at what we have there, this 5 will cancel with the other 5. And we said 1 minus sine squared theta is the same as cos squared theta. So the root of 1 minus sine squared theta will be the root of cos squared theta, which is cos theta. So it's like the square root of 1 minus sine squared theta is the same as cos theta. So what do we remain with after simplifying? It is now the integral of 1 d theta, which is simply d theta. And when you integrate that, you get theta plus c. C is a constant of integration. That is our answer, but we have to replace theta. So you need to check, where did we define our theta? It is this one that I'm bracketing. So make theta the subject. What do we get from here? You get, because you're going to divide by 5, so we'll have x over 5 is equals to sine theta. Then take sine inverse on both sides. So this will give us theta is equals to sine inverse of x over 5. Sine inverse of x over 5. So that's what I'll write here, so that our answer is sine inverse of x over 5, then plus a constant c. That again is very simple. Let me give you another example to illustrate this concept better. So we can talk of part B. Part B of the questions. And in this part, you are told to evaluate the integral of 1 over the square root. Inside there, we have 3 minus 2x minus x squared dx. That's what we have. Now, look at the number or the expression under the square root sign. It is quadratic. So what do we do in this case? Because it is quadratic expression, you first of all must complete the square. That's how we are going to do it. We are going to say that 3 minus 2x minus x squared. So you need to make the coefficient of x squared to be 1. So this can be written as negative. You factor out the negative 1. Inside we have x squared plus 2x, then minus 3. I have factored out the negative so that we have the coefficient of x squared being 1. So the next thing, we need to add a number c, a constant c, and also subtract the same constant. So this can also be written as negative of x squared plus 2x plus that number c. We group this. Then remember there's minus 3. Minus 3. I added c, so I must subtract c. I must subtract c. If I decide to group this, let's have it as that one to avoid a lot of confusion. Now, we said the c we are talking about is given by b over 2, and that should be squared, where b is the coefficient of x. In this case, it is 2. So 2 over 2, that is 1. When you square, you get 1. Remember, b is 2, coefficient of x. So the number we're adding is 1, and so also subtracting 1. So this thing can now be written as negative of x squared plus 2x plus the c, which is 1. This will form one group, minus 3 minus 1. If you simplify, you get negative. Look at the first bracket. First bracket you can factorize, so that's the same as x. You know how to factorize x plus 1 squared. X plus 1 squared is what will give us what we have in the first bracket. So x plus 1 squared, then negative 3 minus 1, that's negative 4. And so if I open the bracket completely, finally we'll have this. It will now be equal to, I'm opening the bracket, taking the negative inside. That's what I'm doing. Take it inside. So that means I'll be having positive 4 minus x plus 1, and that is squared. So that is what we need to write now under the square root sign. So our integral will now be equal to the integral of 1 over the square root of 4 minus x plus 1, and that is supposed to be squared dx. So the next thing, because what you have done here is completing the square method, which at this level I suppose is very easy for everyone. Now we have rewritten our integral or our problem. The next thing is to know what substitution you need to make. So I said you pick everything here. Here it is x plus 1. That is what you pick. And what is our a? Because it is a squared. A squared is 4. So in this case, our a is 2. So you let x plus 1, I said the whole of that, be equal to a, and our a in this case is 2. So we're going to write 2 sine theta. 2 sine theta. Now you need to differentiate the left-hand side and the right-hand side. So we can say that therefore derivative of x, that's dx. Of course, the derivative of 1 is 0, which I don't need to write. Dx is equals to 2 cos theta d theta. So those are the substitutions that we make. Let us substitute them here. So our problem will now be the integral of 1 over the square root. It is square root of 4 minus. Now we square x plus 1. X plus 1, when you square, you get 4 sine squared theta. 4 sine squared theta. Then there was dx. Dx, we have said that should be 2 cos theta d theta. Now, if I simplify, look at the square root. Inside the square root, you realize that 4 is common. So you can factor that 4 out so that our problem now will look like this. In the numerator, we'll have 2 cos theta, the theta. Denominator, when you take 4 outside, it becomes 2. Then now we remain with the square root of 1 minus sine squared theta. Now, you see 2 will cancel with the 2. And I also told you that 1 minus sine squared theta is the same as cos squared theta. So when you take the square root of that, you get cos theta. So the whole of this will cancel with cos theta. So we finally remain with just the integral of the theta, which will give you theta plus c. And that should be our answer, but you need to replace theta so that you leave your answer in terms of x. So to get theta, go back to our substitution. In this substitution, make theta the subject. Start by dividing by 2 so that we have x plus 1 over 2 is equals to sine theta. Then take sine inverse on both sides. So we are going to say that theta is equals to sine inverse, that is sine inverse of x plus 1, and that should be divided by 2. So that our final answer is equal to sine inverse of x plus 1 over 2, and then we add the constant c. C is a constant of integration. So you see how these kind of integrals are very simple to evaluate. So this will mark the end of this lecture. When we meet next week, when we meet next time, we will look at the other form of integrals. Thank you all for your time. Please don't forget to subscribe, comment, like, and also share my channel. Bye-bye.